So the last little bit of the chapter here is on troubleshooting. Starts page 417. So basically, this means something has gone wrong, even though you've been maintaining the system, or maybe you come on a site where somebody has not been maintaining their system. The first one, what you're really going to do is get some data from the system. So if it's working at all, you'll be able to see what the data is. There's one little example here of what you'd expect to see. If this is lower than expected based on the nameplate, then it's time to start going through troubleshooting. And the troubleshooting is broken down into several different levels. Figure 422 breaks it down. So you want to start with the system. So you're going to start with the main connections. If something large and obvious is wrong, like just one of the switches is flipped or a fuse is blown, then your problems are over. So that's where you want to start. If not, you're going to have to dig down into the subsystem and then maybe even to the component and element. And eventually maybe you go up there and see when a little burned out cell somewhere or some damage, what have you. But the main thing is to start big and then go small. And again, you're going to be using your multimeter, testing for continuity, testing for current, testing for voltage, and those should be within specs at each level. If not, then you've basically identified the one component that's wrong. And really, you've probably heard me say this before, but there's always some weakest link in every system. There's one link that's going to break. Obviously, you've got these things wired up in, if the system's large enough, wired up in parallel, so you might have it half working, but the other half, there's one link in the series chain that's broken, and it's not. So, and again, it's important to know as you're doing your troubleshooting if you're on the DC side or the AC side, so that your multimeter is set to the proper setting. And this figure 1423 just sort of breaks it down into, again, system sub-components, any which one can be out of spec. So energy production, obviously that's your array, your combiner box, your array disconnect. There is storage, that's your charge controller and your battery in the bottom. Processing or conditioning, that's your inverter, that's doing your conditioning. Your distribution, that's going back out to the utility. And then consumption, that's your load side. So it breaks it down into 5 main components. And if something's going wrong in the house, maybe you've got a bad appliance rather than something wrong with the system. So it's important to think of it in terms of those 5 different levels. And then if you find something is wrong with the PV system, you get right down into the element level. And as we know, a PV cell is not easily used by itself because it is extremely fragile. And a system would require hundreds of thousands of cells to produce an appreciable amount of power. So, and it could be that your entire module is trashed if you've got a bad cell, so it's important to figure out which module might be out. So then there's a little troubleshooting flow chart here. It says start, so remove GFDI, ground fault detection, fuse, and close AC disconnect. Then you want to close the array disconnect and see if you've got a red LED light is on. Then you'll open the array disconnect, reinsert the fuse, close it again, and see if you've got a red blinking light. There could also be that you've got a ground fault issue in the system, and I don't see that happening pretty frequently. But who knows? Maybe some other utility was in there messing with the plumbing. electrician got in there, didn't know where your array was, so that's basically going through that. That happens all the time too. In the kitchen, you'll get one of your GFCI outlets are broken, and they're always way more sensitive. And the whole point is to allow them to blow, up at the sort of more the touchy-feely level than down in the larger current portions of the system. Okay, and then finally, once you have discovered the problem, it says remediation. When the cause is discovered, it can be remedied, fixing the problem. And almost always, it's going to be swapping out if something truly is damaged, just swapping out a subcomponent. It's great to try to keep fixing your system, but it's just kind of the way electronics are these days. And unfortunately, they're just disposable. And they aren't built by hand. I mean, they're all built in sealed factories, and
Well, the diode goes out on your panel. It's a 5-cent part, so it's in a potted, that box on the back of your panel.
Yeah.
That's where that diode is, to keep the voltage from backflowing through your panel.
Oh, yeah.
At night. And those go wrong. They cost 5 cents, but you'll end up replacing the entire panel because you don't really have the ability to get down inside there and get all that potting material out.
Fix that one little diode, yeah.
And then repot it.
Yeah. It's a little bit of a catch-22 because you could see how the manufacturer would like to make the system trouble-free and service-free. Well, what that means is you can't fix it once it breaks. So it's a little bit of a catch-22 there. And you can also talk about the manufacturer sort of wanting their system to break at just the right time, so you have to buy more.
Well, if it's your own system and you want to fiddle with it, go for it. If it's somebody else and they're paying you $100 an hour to work on their system, sure, you might save them the cost of a solar panel, but how long is it going to take you for the same price? You could have put a brand new one on there. Actually, for less money,
Yeah.
you could have put a brand new panel on and had them back up and running in half an hour.
Yeah. And again, I don't think there's going to be any economics questions on the exam, but obviously there's some time, money things to determine there. And then finally, documentation is critical, and I think now with in the age of smartphones, take a picture went wrong, write a note about it, put it in the report, and that way the customer sees it, the original installer can see it. It's good for your own notes when you go back to do some troubleshooting. It's like, okay, been there, done that, seen that before, and I can now take care of it. So, well, I mean that is pretty much it. I think next week, let's see what we got here, and we'll put up one more study guide there for the NABCEP exam. Yeah, next week is just economic analysis. You can flip through these two. It's kind of just different folks' war stories and what's gone wrong with their own systems. Everything we just covered. Oh, I guess we didn't talk about rodents or bird spikes. But, so not a whole lot there, but it's just what we just covered. Take a look at this guy too. Yeah, at this point, I would just say scan, like, don't try reading this, just scan through it, and if there's something in there, like, oh, shoot, I don't know that, look it up, and just move on. Yeah. yeah. And we have all these tools, kind of nice, at our disposal, so.
If anybody didn't get to see it this weekend and wants to check it out, the PV trainer trailer is here
Yeah.
at the school.
Yeah.
All you do is come see us and we'll.
Yeah,
go over it.
yeah, I think what we'll do, I don't know, maybe rather than drag the thing over to main campus again, maybe we just have folks come over here. What do you think?
Yeah.
For the yeah. So I'm getting asked to take it back over to main campus, but let's just send them over here. Yeah, I think that's best. Okay. Yeah, no, I got some nice photos from the weekend, so we gotta post those too. Well, there's Vicki Watson is holding this thing she calls the Eco Pentathlon. It's it's a Clark Fork cleanup, and it's just raising awareness. But I think it's okay if those guys want to ride their bikes over and clean up some garbage on the way to checking out the trailer. We'll have it here. I think that's better.
People didn't get the opportunity to go to Bozeman, and they didn't get the opportunity to come play this past weekend. Not only can they actually just go in the trailer and look, but we can get them up on the roof. We do have all the safety gear. And if you guys want some actual hands-on, take a panel off, put it back on, see the racking system, that kind of stuff.
Yeah.
That's what it's there for.
Let's do it, okay. What would be a good date for that, maybe, Tim, if you want to, like, schedule something? I mean, I'm almost
It'd have to be
thinking,
this week, because I'm out of town after that.
okay.
Unless you, I mean, you can, obviously, but.
Yeah, I don't mind going up there a little bit, too. When do you take off?
Wednesday.
Okay. Week from tomorrow, right?
Yep.
Okay, good. Yeah. So I'm just going to pull up the calendar here and just look at the rest of the semester. Maybe. Hello. So just looking at the schedule. Anytime Thursday, maybe.
Yeah.
Yeah, okay. So we can be flexible. I'm here all day Thursday. Tim can make himself available on Thursday too, to come and do some hands-on with the new trailer. And then the following Saturday, this coming Saturday, we'll have the trailer also over here in the back lot of the East Campus, so if folks want to come by and see it, we'll have it there to work on too. It's just, we're not moving it. Yeah, it'll just be on here, East Campus the whole time.
At the back of the dirt parking lot.
Yeah. All right, thanks. We'll see you next week for economic analysis.